Yeah, hi everyone. So today I want to talk about PyTorch buffers, what PyTorch buffers are, when we use them, and how they are actually useful. And the reason I want to talk about it is it's, I think, a very important concept if you implement larger models in PyTorch. For example, if you implement a large language model from scratch, you might encounter a concept called a PyTorch buffer. So in code, this would look roughly like this, where you have a line that is like self register buffer in a PyTorch module. And this is actually quite useful concept, as you will see. So this is a pretty spontaneous video, but I will show you with some hands-on coding examples when and how to use these buffers and what the advantages are. So I will try to keep it brief, but I will also try to, make it interesting and relevant. So for that, we will be using a causal attention without buffers PyTorch module that would be technically part of a large language model. So you don't have to understand in detail how the self-attention mechanism here works. The only important aspect is that we have a PyTorch module, PyTorch module here, and we will then see how we or why we would want to use a buffer. So again, the details here, they are not super important for this video. It's just so that we have a hands-on code that we can work with. So how we would run this code is with this following example. So here again, it's just some code that you don't have to really follow in detail. The important part is here that we have some code that we can run. So here, but still maybe because it's interesting. So here we have some inputs. So we have 1, 2, 3, 4, 5, 6 inputs that we arrange as a mini batch. So like in regular deep learning, this is just like a mini batch. Then we have some hyperparameter settings. You don't have to worry really about what these are. What's important is that we are instantiating a new causal attention without buffers object here. And so if you were looking for the buffer, this one doesn't have the buffer yet. I will introduce it in a moment. I wanted to show you first what happens if we don't use buffers, and then I hope this motivates the use of buffers. So here we are now instantiating, here we are using, after instantiating the object, here we are using the object on our batch. And if everything is correct here, we should get some numbers. Again, what these numbers mean, don't worry about it. It's just showing that this attention mechanism, let's say, works on the input. So now we have some code to work with. And usually, as you might know, when you work in deep learning, especially when you work with large language models, you probably want to run things on a GPU. So first, we want to check if this machine has a GPU. So let's do some simple check. So machine has GPU, let's say, and we can say torch CUDA is available. So this should show me, this machine has a GPU. If you're running this on a machine without a GPU, then this buffer might actually not be that useful. So this is kind of like a requirement for, I would say, the usefulness of this particular video or buffer explanation. So now, if we want to run things on the GPU, what we usually do is we transfer the data to the GPU. Let's say, batch to CUDA. So this would be, it's hard to live code for me sometimes because my desk is a different height because of the microphone, and then typing becomes a bit more challenging. Anyway, so let's say we transfer the data to the GPU, and then we do the same thing for the PyTorch module. So we do to CUDA here too. Note that it's like a particular PyTorch thing that for data or tensors, you have to do the assignment like that. Otherwise, it won't be transferred. Or in other words, it will be transferred, but then not assigned to anything. So for modules though, so this is a module, we don't have to do that. So the module here, we just transfer it like that. It's just something in particular about PyTorch. Okay, so let's do that. And so we can see now we have transferred things to the GPU. So what we can do now is, for example, we could run this code and maybe see if everything works correctly. So for example, what we can do is usually when you do a forward pass, I recommend doing no grad, so it doesn't waste memory when constructing a computation graph. So if we're not training, we can do this no grad, and then context back, let's say equals CA without buffer, and then the batch. So this is just calling this like we have here above. Now though, it should run on the GPU because we just transferred things to the GPU. So let's see what happens. Oops, I made a typo. That is what happened. Let's fix that. Okay, so what happened here? So we have a runtime error. And if we look at this error, if we scroll to the bottom, it says expected self and mask. So self here would be referring to this CA without buffer. Expected self and mask to be on the same device, but got mask on CPU and self on CUDA. So this means somehow something got transferred to the GPU and something didn't get transferred. So one might think, okay, there's maybe something wrong here, but let's say everything is correct here. We can actually inspect this a bit further. So what we could do is, so if we look at this class above again, so we could check, are all these things on the GPU? And I will actually tell you exactly the places we will check here. And so one place we will check is, just for reference, this W query, which is a linear layer which contains weights. And then we have, I will draw attention to this triu here. So triu stands for triangular, like the upper triangular matrix. And this is essentially just creating a mask that we use down here. By the way, if you're curious why we are doing it like this, there's also it was a good question in a GitHub discussion. I will probably link this in this video because I've been doing this for efficiency reasons. You could technically down here have the triu every time in the forward, but this would be very expensive. So you would, I would say, lose 30% of the efficiency if you would move the triu from up here to here and redefine it every pass. So I can link a benchmark in my video after recording. But so for now, stay with me. So we have this mask here that we will look at. And we have, let's say, one of the weight matrices. I could also just pick those. But yeah, because it's the first one here, the first row, let's actually take a look at that one. So that one and see if those are actually in fact on the GPU. So let's see. So what we can do is, for example, similar to what we've done before, we just do a simple print. I usually like to do it like that, so I know what belongs to what. So just adding the name here, and then I can do CA without buffer, and then exactly that query. Query. And let's say we look at the weight. So we do device. And with that, we can check, oh, this is actually on a CUDA device. So everything should be fine here. So what now about, what is the other one? Let's call it mask device. And so this would be corresponding to this here. So what happened here? Let's see. Down here. So we do CA without buffer, and then mask, and then device. So what we can see here is that our mask device did not get transferred to the GPU. For some reason, when I executed this code here, somehow the mask stubbornly stayed on the CPU. So why is that? And so the reason is because these are weight parameters. So essentially linear, the weight, I'm not sure if we can show this actually. Let's just try. So you can see this is a parameter, and all the parameters get transferred by PyTorch automatically to the GPU when we execute the toCUDA call. Now the mask, on the other hand, let's try it out here. The mask here is a torch tensor, and torch tensors, they don't get automatically transferred. Now, in order to fix that, what we could do is we could go here and do a torch or just an n dot parameter here and make this a parameter. However, it's also just a convention, or not a convention, but even like implementation wise, the fact that parameters are usually for things you want to learn during training. So they get passed to the optimizer. So we don't want to learn this mask. It's like a fixed mask. So there's no point in learning that. So we actually don't want that. So for that, what we want is actually, we want to make this a buffer. So what I mean is, what we do is we change it to, let's say, comment this out, to self register buffer. And then it's a bit awkward, but we have to provide it as a string. So we will provide this as a string here, which was previously an attribute, and this will become an attribute. So we will have that, and then let me just copy this. So this would be essentially now a registered buffer. So let's run this. So this still works like before. We have everything still set up, everything is still running on the GPU. Now let's do the transfer again. So we transferred, and now, so maybe that's a bit misleading because now it has a buffer. So let's actually change this so to make it not misleading. Yeah, it's a pretty spontaneous video, but it's good to do things properly here. Could have made a second class, but it's what it is. So, okay. It's not defined. Oh, yeah. There we go. So this still works. Our machine is using a GPU still. And we transfer it to the GPU here. And now let's try the with buffer. So what happened? Things worked. Let's print this out. It looks like we fixed the problem. So now we can run the code on the GPU, thanks to the buffer. So if we double check, similar to before, the weight is still on the GPU. Before, we saw that the weight is on the CPU, sorry, the mask is on the CPU. Now, with our buffer, let's see what happens. You can see now it's also transferred to the GPU. So weights is still a parameter, but this mask should be a buffer now. No, it's not actually. Interesting. Okay, it's still a tensor, but it's registered as a buffer. So in that sense, it got transferred to the GPU. So the nice thing is also later, if I decide I don't want this on the GPU anymore, what I can do is I can go here, CA with buffer, say I want this back on the CPU, and then I should see that this is now on the CPU. So I can go basically back and forth, and it should get transferred, as you can see. So yeah, so this was a short, spontaneous video on explaining what buffers are and why they are useful. So this allows us conveniently to transfer all the things in a module that we want on a GPU to the GPU. Without it, parts of it will be transferred, other parts won't, and then yeah, the code won't work as intended. So yeah, I hope this was useful, a short and sweet, I guess, lesson on understanding PyTorch buffers. I hope yeah, you found this useful.